Hello there and welcome to Phosphorus 5. In this video I have an interesting piece of hyperlambda to show you. I want to emphasize this is not yet released, but will be released in version 8.4 of Phosphorus 5. There's a link in the description for the YouTube video where you can check out if version 8.4 has been released or not. Basically, you just open HyperEval. If you want to test it now, you can also, of course, clone the repository. Then you open lambda vs. You can filter here. Lambda-vs. It's a page. Page is basically just a URL in your server. Name page might be a little bit misleading. Now it contains 682 lines of code. If I open it up by clicking the play preview button here, then it shows like this, right? And it allows me to type hyperlambda. Now obviously it executed my hyperlambda, right? And it basically just split my input string, Thomas Hansen is cool, split it by spacebar, and then returned the results of my split invocation. So let's try something else then. p5.mysql.connect camphora. Whoops. And that's the point. You see, in this web server, web service endpoint, I have whitelisted several different active events. The active events that I have whitelisted happens to be active events which I know for a fact are secure. Here is my whole list of whitelisted keywords. Set, add, insert, blah, blah, blah. For each, continue, break. Notice while is not whitelisted because it has the potential to create an infinite loop. Else if, and then all my operators. So all of these active events should be safe, and it should not be possible. I can even do a try catch block if I want to. And it should not be possible to inject malicious code into my web service. Now, so let's try it out to consume it as a web service, because that's actually what it is. It's a web service endpoint. And I can consume it by, for instance, copying this piece of code. Now, of course, my client and my server is the same, so I'm doing a loopback, but it's actually creating an HTTP connection anyways. And let me create a new empty snippet here. Paste in my code. And then let's make sure we view the output of the evaluation of my code. So now it's creating an HTTP post request going towards localhost 480/hypereval/lambda-vs, which is the same URL as my web service. Then it's passing in content type HTTP header as application x hyperlambda, and here is the content of my post request. So I'm actually just transmitting hyperlambda inline to my web service. Let's execute this piece of code. And here we go. So you can see it returned 207. What my code actually did, it multiplied 20 by 10 and then added 7. If we want to use our string split example here, we can do so. oops, let me split it by space, otherwise it's going to split all characters. And in fact, let's try that. Let's try to split all characters. And as you can see, when I evaluate my web service, it actually evaluates my code. So basically, I am transmitting this hyperlambda to this URL, and then that URL will execute using eval this code and return back to the client whatever my code chooses to return. So far, so good. Let's up the stakes. You see, the web service endpoint also supports MIME, and more importantly, PGP encrypted and cryptographically signed MIME entities. So instead of just supplying a simple HTTP POST request, I can supply a much more complex type of POST request where I supply an on-request callback, which once the request is to be serialized will invoke this active event, passing in these arguments to this active event. And all of these parts are heavily documented in Phosphorus 5, by the way. This again creates a MIME entity of type application :x hyperlambda. It encrypts the MIME entity for my server key. I could have supplied a fingerprint here, of course, and then it signs it with my server key. However, since I'm doing a loopback back to my own server, this is enough. If I was doing it from one server to another server and my client server had a different PGP key pair than the web service endpoint, then I would have to supply a fingerprint here. Typically my server's fingerprint, on the signed part, and a password to release my PGP key. Then it supplies content, and then on respose it loads MIME directly from the stream. So let's now have a look at how this looks like. So you saw it took some additional time because, I mean, it needed to decrypt and verify the signature and etc, etc. However, it worked. It was actually capable of encrypting and cryptographically signing my content, sending it to the web service endpoints, which then verified my PGP cryptography signature, then decrypted it, and then evaluated my hyperlambda here. And after evaluation, it returns the results of my hyperlambda as PGP encrypted and cryptographically signed with the server's endpoint's fingerprint. In fact, let me demonstrate how I would normally do this in a real live situation. Fingerprint, password, let's open up HyperID and figure out our password. Actually, web.config, find GNU, copy, close. Let's try it again, make sure it works. And it works. So this allows a client and a server to communicate with each other using PGP cryptography and cryptographically signed MIME envelopes, passing in multiple snippets of hyperlambda back and forth to each other, and have these snippets evaluated on the server. Which I just think is staggeringly cool. If you look at how the web service is actually implemented, let's open it up. MWS. You will see its description here, heavily actually documenting the thing. And in fact, if you view the help file for it, you will see that it's actually marked down. Let me see, hyper-eval, meta. Should probably be one, yeah, here is one of those really long parts. Here you can see what it actually does. This is extracted using meta services of the help system. And here I can force PGP. If I set this to true, then my first example code, simply transmitting hyperlambda as a body of a normal HTTP post request, won't work, right? In addition, I have a whitelisted servers here. If I use my fingerprint here for my private PGP key here, and I supply it here, and I uncomment this line, then only cryptographically, and I set this to true, then only cryptographically signed PGP envelopes that are cryptographically signed with this fingerprint are legally allowed to invoke my web service endpoint. And of course I can have as many fingerprints as I want to, whitelisting basically a whole bunch of servers if I want to. Let me just undo this. Then, in addition, I can modify the list of legal active events. For instance, if I whitelist only a bunch of servers, which I happen to like completely trust down to the bone, then I can whitelist stuff like MySQL, select operation, connect, insert, whatever, etc., allowing me to use a cryptographic guarantee for communicating between only a handful of trusted clients, allowing them to evaluate any piece of hyperlambda on my server. Here you can see it checks to see if it's a post method. These are the web service parts, roughly the bulk of the code, 500 lines of code, almost 400. And inside of here, it checks to see if the method is post. If it is, it assumes it's a web service invocation. Otherwise, it just shows the GUI like it did here. And it will get the content type of the request. If it's application hyperlambda, it assumes it's just dummy hyperlambda, not PGP encrypted or anything. If it's anything besides that, then it will assume it's a MIME web service invocation. At which point it requires the caller to at the very least have cryptographically signed the envelope, not necessarily encrypted it, however you probably should do that too. Then it will parse the MIME and it will loop through every single application hyperlambda MIME leaf part and evaluate it. And in fact, let's try some more complex types of requests here. Let's copy this guy and then let's create a new empty guy. And let's create multiple of these guys. Return foo bar. So now I have two hyperlambda entities in my MIME envelope. And I'm still passing it. Well, actually at this point I should probably wrap everything in a multi-part mixed guy. And then encrypt the whole envelope and have my application hyperlambda entities inside of my encrypted multi-part mixed node. It didn't work for some reasons. Why didn't it work? Content, return, oops. There we go, and now it worked. And now you can see it evaluated both of my hyperlambda snippets. If I just return a simple value, then it will return a text plain part back to caller. If I return hyperlambda or a lambda structure, it will return it as application X hyperlambda. And I can identify my different snippets by doing X colon hyperlambda dash ID first dash snippets second snippet, which allows me to uniquely identify my hyperlambda snippets and have the web service endpoint actually return that ID back to me, such that I can see what is the result of what. Here is the result of first snippet, and here is the result of second snippet. I can also transmit files. File column, text column plain, content, file name, startup.hl, at which point it's going to serialize that file directly onto the stream going towards the web service endpoint and never ever load up that file into memory. At which point I can do something slightly more complex here. MIME file name. Actually, let's return the whole file name. And the folder value, prefix value, file name. You see, the web service endpoint needs to, and that didn't work for some reasons, because I didn't use it as a reference node. Let's try again. And now it worked. You see, the web service endpoint, when you pass in file attachments, it will store these files in a temporary folder, and for as long as the web server, and it will also randomize its name to make sure it gets unique file names. And then after the web service invocation is done, it will loop through all of these files and delete them, such that you don't have, like, you know, old files hanging around on your server. However, I can actually temporarily access these files. If I go to my, if I would, for instance, allow, well, let's do that in fact. Let me just copy this code first. And then let's allow load file here, right? Load file, and well, I guess that's it. Save. Then let's create a new empty guy, and then let's inside of here do load file, return colon x colon minus count, which is going to do the total count of the total nodes in the files and return in that file and return that to caller. Then when I evaluate my web service invocation, I need to also do has access. So there's a couple of more active events I need to whitelist. However, it doesn't matter. The point is, I actually was able to invoke and load that file dynamically in my content in my hyperlambda here. So, and it allows for, let's find, just, oops. It allows me to also, if you see in the web service code, you can see at the, actually we can see it in the description for it. that if we create an active event whose name is hyper-eval lambda vs dot authorize fingerprint, then we can return an additional set of active event names. Let's do that. Hyper-eval.lambda vs authorize fingerprint. Create event hyper-eval.lambda vs dot authorize fingerprint. And of course, at this point, we're given the fingerprint as arg, so let's check if. Let me just paste down the code I've got on my clipboard so I don't have to create it again. And then let's find the fingerprint for the key I trust. Return load file p5.auth.has access, and I should probably whitelist a couple of other events too. However, it doesn't matter, I'm just here to illustrate the point really. Now, since I am the client and the server is the same thing, I can do this on my client, right? However, this event should probably, in a real live production, you would create this event on your server. And then when, before it tries to evaluate your hyperlambda, it will invoke this active event with the fingerprint, at which point you can whitelist and check the fingerprint if it is a resource you are particularly more trusting to do additional things. Then you can return additional keywords which are appended into your existing list of legal active events. Let's try this out. Actually, let's do load file. I think it should probably work now. Caller try to has access, okay. We did that one. And there we go. And now it worked. So this fingerprint here, if I pass this on a cryptographically signed MIME entity that has been cryptographically signed with this fingerprint, or the PGP key having this fingerprint, then it will additionally whitelist two active events, allowing me to load the file and also call p5.auth.has access. And well, in general, I think this is a pretty cool thing. It basically allows you to invoke and create and instantiate PGP, cryptographically signed and encrypted lambda web services where the client passes code to the server that is evaluated on the server, and where the results of that evaluation is returned back to the client again. Literally allowing you to 100% cryptographically secured implement a single web service endpoint where the client submits the code. And of course, I'm using the same client and server here in this scenario. However, you can easily use like anything as long as you're capable of somehow actually creating hyperlambda. You could use like Xamarin Forms client. You could create hyperlambda in C# easily if you wanted to, and you can pass to some web service endpoint, etc., etc. And that's pretty cool, I think. Thanks for watching. Have a nice day.